Alright, so now we're just going to talk about expanding numbers beyond just the pure imaginary numbers that involve I into what we call the complex numbers. Complex numbers look like this: a plus bi. Of course, b could be negative, so this doesn't have to be an addition, it could be a subtraction. But a and b are both real numbers, and so a is the real part, b is the imaginary part because it's with the I, and when you combine a real part with an imaginary part, it becomes a complex number. Just something to think about. So what can we do with these things? Well, for addition and subtraction with complex numbers, we just pretty much combine like terms as if the I was a variable. So for 3 plus 6i plus 4 minus 2i, I have an addition, so I'm going to add 3 and 4, which is going to be 7. And I'm going to add 6i and negative 2i, which is positive 4i. And then 7 plus 4i can't be combined any further. That's just a different complex number, and I'm done. The second problem, which is a subtraction, my suggestion there is that you rewrite the second part of your problem by distributing your negative, and that's going to change the signs in the second part there. Now it's a little bit easier to combine like terms. And 3 minus 4 is negative 1. 6i plus 2i is plus 8i. And that's now your final answer. Now, normally, I like to format things. If I have a negative plus something, I normally would put the positive thing in front and have it just be a subtraction. But with complex numbers, we write the real number part first and then the imaginary part. So we're going to have the negative 1 plus the 8i. It's just kind of the way that we do it. All right, so addition and subtraction is really very, very straightforward. Nothing that should surprise you there. Multiplication is actually not that much more difficult. We have to remember the fact that I squared is negative 1, and that changes some things at the end. But for multiplication, we're going to FOIL or use a Punnett square, whatever method we use. So I'm going to have 3 times 2, 3 times negative 3i, 4i times 2, and 4i times negative 3i. So that's going to give me 6 minus 9i plus 8i minus 12i squared. So I can combine the like terms in the middle there. Negative 9i plus 8i is minus I. I don't need the 1. And I'm going to say, instead of minus 12i squared, I'm going to make that a negative 1 to multiply by my 12. Which is going to give me 6 minus I plus 12. And then I can combine like terms and get 18 minus I. That'll be my final answer right there. I shouldn't end up with an I squared in my final answer. 2 plus I squared. Do not make this 2 squared plus I squared. That would equal 4 plus negative 1, which is 3. That's not going to be the case. What you might want to do is rewrite it as 2 plus 1. 2 plus I times 2 plus I. And then draw your multiplication in, and you'll see that you'll have 2 times 2 is 4, but you have other pieces in the middle as well, the plus 2i, plus another 2i, and then plus I squared. Now when you combine your like terms, you do have 4 plus 4i plus negative 1. And so you do get 3 as part of your answer, but if we didn't FOIL, we would have lost track of the 4i. And so that's what you need to do. That's how you simplify. Pretty straightforward again, as long as you remember to make your I squared into a negative 1 and then combine it. Okay, probably the trickiest part here, which isn't even all that bad, is division. For division, just like with radicals here, we need to clear out our radical from the denominator, and I is a radical. So we're going to set up a difference of squares using the conjugate of the denominator. Here in my first example, 2 divided by 3 plus 2i, I'm going to multiply by the conjugate of the denominator, which is 3 minus 2i. So that's going to be up top as well. Now, in the numerator, that's just going to be a distributive property, so 2 times 3 is 6, minus 2 times 2i is 4i, and in my denominator, it's a difference of squares, 3 plus 2i times 3 minus 2i, so I'm going to get 3 squared, which is 9, minus 2i squared, which is 4i squared. So 6 minus 4i is what I have my numerator, and 4i squared, well, the I squared is negative 1, so it's going to turn the minus 4 into a plus 4, is really what's happening there. And that leaves me with my final answer of 6 minus 4i over 13. And that's kind of one way that we can write it. If we really wanted to write it with the real part and the imaginary part, sometimes you'll see it written as 6/13 minus 4/13 I. That's just an alternative. You don't need to write it that way. Let me fix up that numerator there, make it look a little bit nicer. There we go. And you can see that none of that's going to reduce. So either of these boxed in answers would be acceptable. That's kind of up to you. Same type of thing with the second example, except I'm starting with a subtraction. So my conjugate's going to be an addition, the 1 plus I. And I multiply that up. In my numerator, I'm going to have to FOIL. So when I multiply my numerator, I get 2 times 1 is 2. Outside is plus 2i, then plus 3i, a little tough to read there, plus 3i squared. And my denominator is going to be 1 squared minus I squared. Now, to combine like terms here, I've got a 2, and I'm going to add to it 3i squared. Well, 3i squared is negative 3, so 2 minus 3 is going to be negative 1. And I'm going to have 2i plus 3i is plus 5i. And then in my denominator, it's going to be 1 squared minus negative 1, or 1 squared plus 1, which is 2. And that's it. You can either leave your answer like that, or, as I said before, negative 1/2 plus 5/2 I. So now it's kind of in that A plus BI look. Either of those would be acceptable. Sometimes the numbers will reduce really nicely. If this was negative 2 plus 4i over 2, I could reduce everything by a factor of 2. That will happen. That'll happen on your practice. But this is the idea, and you just simplify from there. All right, hope this makes sense.